Welcome back, everyone, to the Deep Dive. We always bring you the most interesting stuff, and, well, today is no different. We're going to be looking at a really cool new robot gripper. It's called MOGrip, and it's been making some waves in the robotics world. It was just published this month.
Yeah, it just came out.
And we had to dive right into it because
Hot off the press.
it's pretty mind-blowing. So this gripper, it's inspired by human hands, and get this, it can move multiple objects at once, just like we can.
It is pretty amazing when you think about it. I mean, we as humans can just pick up like a handful of coins or, move things between our fingers and our palm without even thinking about it.
Right. It's so natural for us.
Yeah, but it's a really complex thing to get a robot to do.
Yeah, exactly. And those conventional robot grippers we've seen, they're great at picking up one thing at a time. But when it comes to like precise placement of multiple items, they struggle. They just can't quite get it right. So how does MOGrip tackle this? What makes it so special?
Well, it's all about mimicking how our hands work. That efficiency, that versatility in moving multiple objects. So they really focused on replicating those human motions in the design.
Okay, so walk me through this. How does it actually work? What does this thing look like?
Right, so picture this. MOGrip has 4 fingers, just like a human hand. Each of those fingers has 2 tendons, one for grabbing an object and another one for smoothly moving that object towards the palm.
Okay, 2 tendons per finger. Got it.
But here's where it gets interesting. The palm isn't just a flat surface. It actually has a conveyor belt built right into it.
A conveyor belt, like a miniature one? What's that for?
Exactly, a miniature conveyor belt. And that's one of the things that really sets MOGrip apart. That conveyor belt is what allows it to handle multiple objects at the same time.
So how does that work? How do the fingers and the conveyor belt play together?
Okay, so imagine this. Each finger picks up an object. As the finger brings the object towards the palm, the conveyor belt starts rotating. And it's perfectly timed so that as the object reaches the palm, the belt gently moves it into position. And here's the cool part. The belt has these little elastic hairs embedded along its surface.
Hairy belts. Now, that's something I wasn't expecting.
Right. Sounds a bit odd, but trust me.
Okay, so it's not just a smooth conveyor belt. It's got these little hairs on it. What's the purpose of those?
Oh, those hairs are super important. They're not just for looks. They're actually critical to how MOGrip grips and stores those multiple objects securely. Think about it. If it was just a smooth belt, things could easily slip and slide around, especially if they're different sizes. Not very efficient.
Yeah, that makes sense. So the hairs help create a more stable grip.
Exactly. It's actually inspired by gecko feet. You know how they can cling to walls using those tiny hairs?
Oh, yeah, it's amazing how they do that.
Yeah, so those hairs on the conveyor belt create a similar kind of passive gripping force, helping to keep everything in place, even when the palm is holding a bunch of different objects.
Wow, that's some clever engineering, taking inspiration from nature to solve a complex robotics challenge. So we've got the basic design, but how does MOGrip actually stack up against existing solutions? Is it really a step forward in multi-object grasping?
That's the big question, right?
Yeah.
And this is where it gets interesting. You see, we've had robot grippers with multiple fingers before, but what sets MOGrip apart is this. It's specifically designed to mimic those human hand motions. Remember those 2 key strategies we talked about earlier? The finger to palm and palm to finger.
Yeah, like when we gather a bunch of coins, then move them into our palm to free up our fingers for more.
Exactly. MOGrip is built to replicate those exact motions, and that's where it really shines. It's not just about grasping multiple objects, it's about that coordinated movement between fingers and palm that makes multi-object manipulation so efficient.
So it's not just about having a bunch of fingers. It's about how those fingers work together with the palm to mimic our own movements.
Precisely. And that design translates into some pretty impressive results in the real world.
Okay, I'm all ears. Tell me about how they tested this thing. Did it live up to the hype?
Oh, they really put MOGrip through its paces. Tested it with all sorts of objects, different shapes, different sizes, and overall the results were really impressive. Showed a high success rate in grasping and accurately placing all those objects.
That's great. But were there any hiccups? Anything it couldn't quite handle?
Well, it wasn't all smooth sailing. You know how you mentioned cylinders before? Turns out they were a bit trickier to handle than those nice square cuboid shapes.
Oh yeah, I can imagine them rolling around and causing trouble.
Exactly. And just like we sometimes struggle with grasping things off-center, MOGrip had a bit of a challenge with that too. Or if they tried to move an object against gravity, that could cause some issues.
So even with those challenges, it still showed a lot of promise in handling multiple objects. But let's get practical here. How does this actually translate into real-world applications?
Mm.
Can you really see this thing working in a factory or a warehouse?
Oh, absolutely. In fact, to show just how practical it is, the researchers built a mini warehouse environment,
Right.
kind of like a simulation.
Yep.
And they had MOGrip move multiple objects from one location to another, and they compared its performance to a typical single object gripper.
Oh, so it was a head-to-head competition. What happened?
The difference was remarkable. MOGrip was able to achieve a 71% reduction in travel distance
Wow.
and a 34% decrease in the overall process time.
That's a huge improvement. I mean, those kinds of efficiency gains could be massive for industries like logistics where every second counts.
Absolutely. And it's not just limited to warehouses and factories. They also tested MOGrip in what they called a domestic environment.
What, like a home setting?
Yeah, like a home
Fair.
setting. And
Yeah.
get this, they had it successfully tidy up a desk.
Wait a minute, are you telling me this robot could help me with my messy desk? Now we're talking.
Oh, I know, right?
Sign me up.
So it picked up things like a lotion bottle, a toothbrush, a razor, and put each item in its designated spot. And all in all, they tested it with a whole range of 23 different objects.
23? That's amazing. So it's not just a one-trick pony. It can really handle a variety of things. It really sounds like this technology has the potential to change not just industrial automation, but also the way robots can actually help us in our daily lives.
It really does. It's pretty exciting stuff. But before we get too carried away with all the amazing possibilities,
Yeah.
it is important to remember that MOGrip isn't perfect, right?
Right.
We talked about those cylinders being a challenge, and then there were those issues with grasping objects that weren't centered and moving things against gravity.
Yeah, no system is perfect.
Yeah.
It's good to be aware of those limitations as we think about how this technology could be used.
Exactly. But even with those limitations, the researchers are already looking at ways to make MOGrip even better.
Ugh. What are they thinking? Are they going to add more hair to those belts?
Haha, maybe not more hair this time. One of the main things they want to do is give MOGrip a sense of touch
Oh, interesting.
by adding a sensing system so it could actually feel the objects it's grasping.
That would be a game changer. What kind of sensors are we talking about here, and how would that work?
Well, they're exploring a few different options.
Mm-hmm.
One idea is to use tactile sensors,
Okay.
like the ones that are sensitive to pressure and texture,
Mm-hmm.
and those would be embedded right into the fingertips and the palm. So it could actually get a feel for the objects almost like our own skin.
Wow. So it would be able to sense things like how hard it's gripping, whether an object is smooth or rough, maybe even the temperature.
Yeah, exactly. And having that kind of sensory feedback would give MOGrip a whole new level of awareness and control, right? It could adjust how strongly it grips depending on how delicate an object is. Or maybe that even sense if something is slippery and needs a tighter hold.
So we're not just talking about a robot blindly grabbing things anymore.
Yeah.
It would actually be able to handle objects with the same kind of care and precision as a human.
Exactly. It's a huge step forward. And it's not just about tactile sensors either. They're also thinking about adding cameras to the system.
Like giving it eyes.
Yeah.
So it can actually see what it's doing.
Yes, precisely. So it would have that visual information about the shape and size and orientation of the object, and that would work together with those tactile sensors to give it a really complete understanding of what it's dealing with.
It's mind-blowing to think how those different types of sensory input could transform MOGrip from a clever machine into something that almost have a human-like awareness of the world.
I know, it's pretty amazing, right?
It really is.
It really is. And it takes us closer to having robots that can truly interact with their environment in a much more intuitive and adaptable way.
So we talked about sensory upgrades, but what about those improvements to the fingers? You mentioned giving them more degrees of freedom. What kind of impact would that have on what MOGrip can do?
That's where it gets really exciting. If you give those fingers more flexibility, MOGrip could move beyond just picking things up and putting them down. We're talking about manipulating objects in all sorts of complex ways.
Manipulate? What do you mean by that? Give me some examples.
Well, imagine this. MOGrip could be holding an object and then rotating it at the same time, or using its fingers to assemble small parts. Think about screwing on a bottle cap, turning a key in a lock, even threading a needle.
Now, those are some serious dexterity skills. That would open up so many possibilities for automation.
Oh, yeah, absolutely. This could be a game changer for industries like manufacturing and assembly, where you need really precise and delicate movements.
But it's not just about factories and assembly lines, right? Yeah. I can also see this being huge for assistive robotics. Think about a robot that could actually help people with disabilities do everyday things that they might need help with.
Exactly. Like getting dressed or preparing a meal, or even personal hygiene tasks.
Yeah, it would be like having an extra pair of hands, but with the precision and the strength of a machine.
Precisely. And as artificial intelligence and machine learning keep advancing, those robotic hands could become even better at understanding our needs and responding to them.
This deep dive started with us talking about robots picking up boxes in a warehouse. And now we're imagining a future where robots can help us cook dinner or even perform surgery. It's really mind-blowing.
It is, isn't it? And it all comes back to the incredible pace of innovation in robotics. And what's even more exciting is that we're really just at the beginning. There's so much more to come.
I have a feeling that in a few years, we'll look back at MOGrip as one of the first steps towards a future where robots aren't just machines anymore. They'll be true partners in our everyday lives.
It's a future worth working towards. A future where robots and humans can really collaborate, using each other's strengths to make the world better, more efficient, more accessible for everyone.
I gotta say, I'm feeling pretty inspired right now. Thanks for taking this deep dive with me into the world of MOGrip and the future of robotics. It's been a fascinating journey.
It's been my pleasure. And to everyone listening, keep exploring, keep asking questions, keep imagining the possibilities. Who knows, maybe you'll be the one to invent the next big breakthrough in robotics.
Until next time, keep those minds curious and those imaginations fired up. It really is amazing how far robotics has come. Just a few years ago, something like this would have seemed like science fiction. And now here we are talking about robots that can practically mimic our own movements. It's incredible.
Yeah, and we were talking about those human hand motions earlier, like finger to palm and palm to finger. Those are really key to how MOGrip works.
Right, like when you pick up a bunch of coins and then slide them into your palm so you can free up your fingers to grab more stuff. It's something we do without even thinking about it.
Exactly. And MOGrip is designed to do the exact same thing. So do you remember how we were talking about each finger having those two tendons, one for grasping and one for moving the object towards the palm?
Yeah, I remember that.
So as that finger brings the object closer to the palm, the conveyor belt starts rotating at the same time.
Oh, so they move together in sync. That's pretty cool.
It is, and it's all perfectly timed so that the belt can gently guide that object right between those little elastic hairs, and it creates this really neat storage system right there in the palm.
I'm picturing it now. It's like a miniature assembly line happening right there in the gripper. But, I have to admit, I'm still a little stuck on those hairy belts. I get that they help with grip, but why not just use a flat surface? Wouldn't that be simpler?
Yeah, a flat belt might seem like the more obvious choice at first, but the researchers actually started with that design and they quickly realized it had some major drawbacks.
What kind of drawbacks?
Well, a flat surface just wouldn't be stable enough for storing multiple objects, especially if they were different sizes. Things would be sliding all over the place, they could get jammed, or even fall out of the gripper altogether.
Yeah, that wouldn't be very efficient.
Not at all.
Yeah.
So that's where those little hairs come in. They act like tiny little grippers themselves, preventing that slippage and keeping everything nice and organized.
So it's like having hundreds of little fingers holding on to each object. Is that right?
That's a great way to put it. They create a much larger contact area with the objects, which means a more secure grip no matter what shape or size they are.
So it's not just about mimicking the big movements of the hand. It's also about replicating that subtle gripping force that our fingers provide.
Exactly. And the amazing thing is that the grip actually gets stronger as you add more objects.
Wait, really? I would have thought the opposite. Wouldn't those hairs get overcrowded and lose their effectiveness?
You'd think so, right? But the testing showed that wasn't the case. When you add a new object, it actually compresses the hairs between the objects that are already there, and that increases the overall grip.
So it's like a self-reinforcing system. The more it holds, the stronger it gets.
Yeah.
It's pretty ingenious.
It really is. It's a great example of how a simple design element can lead to these really unexpected and beneficial outcomes.
So we've talked a lot about those impressive results in the warehouse demonstration, the time savings and all that. But what about that domestic environment test? Did it actually manage to tidy up a desk like they said it would?
It did. They set up this simulated desk environment with things like a lotion bottle and a toothbrush, a razor, and a few other objects. And MOGrip was able to pick each one up and put it in its designated spot.
That's incredible.
Yeah.
I can definitely see this being a game changer for people who have difficulty with those kinds of tasks, or even just anyone who hates cleaning up clutter.
Absolutely. And they actually tested it with a total of 23 different objects, so it wasn't just a one-off demonstration.
23, that's pretty impressive. It really seems like this technology could revolutionize not just industrial automation, but also how robots can assist us in our daily lives.
I think so, but before we get too carried away with all the possibilities, we should remember that MOGrip does have some limitations, like we talked about. Those cylinders were tricky, and then there were the issues with grasping off-center and working against gravity.
Yeah, you're right. No system is perfect. It's important to keep those limitations in mind as we think about the potential applications.
Exactly. And even with those challenges, the researchers are already working on ways to improve MOGrip even further.
What kind of improvements are they thinking about? Are we going to see even hairier bolts?
Uh-huh. Who knows, maybe. But one of their main goals is to give MOGrip a sense of touch by adding a sensing system so it can actually feel the objects it's grasping.
That would be incredible. Imagine a robot that can actually sense what it's holding. That would open up so many possibilities.
It would, right? Imagine it being able to tell the difference between a delicate wine glass and a heavy book and adjust its grip accordingly so it doesn't break anything.
That's amazing.
Uh,
It would be like having a robot butler with the dexterity and sensitivity of a human hand.
exactly. And it would bring us one step closer to robots that can truly interact with the world in a way that's more intuitive and adaptable.
So this deep dive has really given me a whole new appreciation for how complex our own hands are and how much potential there is for robots to learn from them and maybe even surpass our capabilities.
It's true, and it's really an exciting time to be following the world of robotics, with researchers constantly pushing the boundaries of what's possible. Who knows what incredible breakthroughs we'll see in the years to come.
It's really remarkable to think that robots might be on the verge of being able to interact with the world with the same kind of dexterity that we have. And the fact that MOGrip is inspired by something as basic as the human hand, well, it just makes it all the more fascinating.
I know, it's like sometimes the best solutions are right in front of us. We've been trying to design robots with dexterity for decades, and it turns out that one of the best blueprints was literally attached to our arms the whole time.
It really shows the power of looking to nature for inspiration. But you were talking about adding a sensing system to MOGrip. Can you tell me a little more about what kind of sensors they're considering and how those would actually work?
Well, one of the main options they're looking at is tactile sensors. You know, the kind that can sense pressure and texture, and those would be embedded in the fingertips and the palm, so MOGrip could actually feel the objects it's grasping.
Oh, so it would be like giving it a sense of touch, almost like our own skin.
Exactly, and that would give it a whole new level of awareness and control. It could adjust how firmly it's gripping something based on whether it's delicate or not, or even sense if something is slippery and needs a tighter hold.
So it wouldn't just be grabbing things blindly anymore. It would be able to handle objects with the same kind of care and precision as a human.
That's the idea. And it's
Yeah.
not just tactile sensors. They're also looking at integrating cameras into the system.
Oh, so it would be like giving it eyes so it can see what it's doing.
Precisely. It could get visual information about the shape and size and position of the object, and that would work together with the tactile data to create a really complete understanding of what it's dealing with.
It's amazing to think how combining different types of sensory input could make MOGrip even more advanced, almost like giving it a human-like awareness of its surroundings.
Yeah, it really takes us one step closer to having robots that can interact with the world in a more natural and adaptable way. But we were also talking about improving the finger design. You know, giving those fingers more flexibility. What kind of impact would that have?
Yeah, what could it do with more flexible fingers?
Well, imagine MOGrip being able to not just pick up objects, but actually manipulate them in more complex ways.
Okay, manipulate. What does that mean exactly? Give me some examples.
Well, picture this. It could be holding an object and rotating it at the same time, or even using its fingers to assemble small parts. Think about screwing on a bottle cap, or turning a key in a lock, or even threading a needle.
Those are some pretty impressive feats of dexterity. It sounds like it would open up a whole new realm of possibilities.
Oh, definitely. It would be a game changer for things like manufacturing and assembly lines where you need those really precise and intricate movements.
But it's not just about industrial applications. I can also see this having a huge impact on assistive robotics. You know, imagine a robot that could help people with disabilities do everyday things that they might need help with.
That's a great point. It could be like having an extra set of hands with the precision and strength of a machine.
Right, it could help someone get dressed or prepare a meal or even assist with personal hygiene tasks. The possibilities are endless.
Exactly. And as artificial intelligence and machine learning continue to advance, those robotic hands could become even better at understanding and responding to our needs.
This has been a real eye-opener. I started out thinking about robots moving boxes in a warehouse, and now we're talking about robots that could help us with everything from cooking dinner to potentially even performing surgery. The future's pretty amazing.
I know, and what's even more exciting is that we're really just scratching the surface of what's possible in the field of robotics.
Well, after this deep dive, I really feel like we're on the verge of a new era of robotics. One where robots aren't just machines anymore, but true partners in our everyday lives.
It's a future worth striving for, one where robots and humans can work together, combining our strengths to make the world a better place.
Well, I don't know about you, but I'm feeling pretty inspired. Thanks for joining me on this incredible journey into the world of MOGrip and the future of robotics.
The pleasure was all mine, and to everyone listening out there, keep your minds curious and don't be afraid to dream big, because who knows, maybe you'll be the one to invent the next groundbreaking robotic innovation.
Until next time, keep exploring and keep those imaginations running wild.